Hello and welcome. Today is Wednesday, August 19th. Today, my plan is to do something slightly different. What I want to do today is I want to prepare for doing something that is really challenging for me. I want to prepare for a hackathon, which is being hosted with NVIDIA and Dell. My friend Somya Gupta, he is a venture scout at a European-based venture capital firm. He's based in New York City, but the firm is based over there. It's called eWar, and he invited me to a hackathon, and I want to prepare for doing this because I've never used anything from NVIDIA. And so, because a lot of my knowledge there is limited, my goal is I want to learn out loud. I want to show you exactly how I'm going to go from being someone who's like, I have no idea, kind of the first thing about how to work with this, to having a meaningful plan and strategy for trying to win the hackathon. So, the goals of today's session, it's inspired by, if you guys know predictive history, we have Professor Jung Shutkin, and I got a chance to meet him last week. He's a personal hero of mine, and when I got a chance to listen to all of my other peers in the lecture ask questions, there was another teacher who was in the room. I teach adults. This other teacher was a middle school teacher. What he asked, he asked to Jung, he said, what can we do as teachers? And what Jung said is really making me rethink myself as a teacher. He said that in every single class, you need to know how to admit when you're wrong. And so, to keep honor with that, what I would like to do is I want to just try doing something that I don't know how to do. And in the process, yes, I am going to make mistakes. And yes, I will position myself as someone who's less technical than what I really am. However, I think this is going to get to the most important thing that I can do, which is whenever we try to create an AI application, the most important foundation is being able to align with the humans that are going to use and maintain the AI as well as the end users. I think that this is probably the biggest gap right now because Dario Amodei from Anthropic just kind of talks about over and over about how his AI is going to wipe out humanity and ruin our civilization. And I think that's one of the big things that is going to cause the public markets to not accept any of Dario's warnings going forward, is that you have to learn to align with other humans, not just people who are in your cult. And so I do think that that is like a very important thing. So now, with those things being said, let's go ahead and let's try to prepare for the hackathon. Let me just kind of make this a little bit smaller. I'm going to keep the picture there just because like it makes me really happy, because it was really such a special moment for me. What I'm going to do now is I am going to try to, let's see if there's a feature in here where I can do like a split view. Yeah, it looks like I can. And so then I would be able to pick something in here, but I don't have the requisite tab for doing this. So let me come back and I guess, let's see, I may have to do it like this. And then I'll come into here and then I'll do this. And then now this will show up real nice. And yeah, we see that on the screen. So now I can definitely nuke that over there. So here we go. This is the hackathon. They're calling this the AI Factory with NVIDIA. The goal is to use local AI on a Dell Pro Max. So, right, let's write these things down. So I'm going to say Dell Pro Max with GB10. GB10 stands for Grace Blackwell 10. This is a very specific type of GPU from NVIDIA. So Dell and NVIDIA's local AI on Dell Pro Max with GB10 is a one-day build sprint. You ship an always-on business agent running locally. So immediately, when we talk about having an always-on agent, specifically, this means what type of agent would we have? So I'm going to define this as agent type. And our options for agent type is going to be ambient. It is also going to be a deep agent. And then I think that there's another type of agent. And hold on, when I say a deep agent, I'm going to say long horizon, meaning it's just going to do like a deep task. And then another type is going to be like, it has the ability to awaken itself. And so these are the types that I will kind of notice. And then I'll say, there's another thing, there's plurality. Is this a single agent or is this a multi-agent? And this is going to cause challenges with respect to memory if we're going to have the space. And so our sponsors on the hackathon are Dell, NVIDIA, and MongoDB. Usually they try to force you to use whatever stuff they're hawking. Um, so there's going to be 40 teams, and each team will get this Dell Pro Max with GB10. And so the specifications that we can expect here is that this is the NVIDIA GB10 Grace CPU. So I was incorrect immediately uh, by calling it, like, I think I'm just referring to this like incorrectly. So I got to take that immediately as, okay, I'm wrong, even about how I talk about the NVIDIA hardware. Okay. So as I continue going through the features and the technical specifications, this is something that I am going to have to look at. And the reason I will look at this is that specifically they want us to, oh my God, it's so annoying. I guess every time you click on this, like, this is such a stupid way to include a link. Um, oh my goodness, what a terrible website. All right. So, blah, blah, blah. 12 hours of hacking. So 12 hours of free work. All right, bring your startup, blah, blah, blah. I have to say, like, the hackathon organizer, I don't like this, but I mean, I see the general trajectory that hackathons are going in. Um, but I have to say, so far, like, if I didn't already know Somya, I would never join this. Okay, blah, 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 blah. All right, and so now business and corporate use cases, required stack. So, I mean, I have to say, I've never read a hackathon description that made me this unexcited. I think there's a lot right now. I think that a lot of people who are doing hackathons, 99.9% of hackathons are starting to look like this, but this is just like, personally, I find this to be something that makes you dumber intellectually, is this hackathon, whereas the lectures from Jung, they make me so much stronger with my imagination. I know that the market is focused on this type of shit right here, but I really have to start calling out the AI labs and the other companies here because this sucks. I'm gonna just keep going forward because this is like not what I want to spend my time on. Okay, so we have a required stack. I'm gonna define what these things are because like this, like, and as we see, you'll see my frustration with this of like kind of how stupid I'm thinking this is, and it's not. And the reason I'm calling this stupid is predominantly because this is a very sophomoric effort of putting a hackathon together while forcing other people to pick up all of your slack. So you're going to do something like an amateur, and you're going to do something sophomoric, and then you're going to gaslight all of your participants that if we don't understand this, we're stupid. So this is one of the biggest things that I already don't like about this. Okay, so now I'm going to get into what the stack is. And in the stack selection, this is why. And so what I'm going to write here quickly is stupid and sophomoric. I'll put this in red. And so like, let's go in. So it's saying like, oh, this is your required stack. This is like this is like the stupidest part of AI speak that I see. Let's go into the stupidity. So first we have OpenClaw, NemoClaw, and then we have OpenShell. Now, let me get into why this is sophomoric. And right, the reason why I'm saying this is sophomoric is that it's saying you must pick two of these three things. Let's define what these things are, and then you will see why I'm going to call them stupid. Okay, so the first thing I'm going to do, let's look up what is NemoClaw. Now, this is going to be really important. So look, this is a secure, always-on autonomous agent for real-world workflows with open blueprints, blah, 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 blah. Jensen, I respect Jensen. He's a super cool guy, so not going to say anything about that. Great. So NemoClaw is a secure, always-on autonomous agent. Okay, well then what is OpenClaw? Now we'll get to the stupidity. OpenClaw. Open source AI that runs on your... Wait a second. Isn't this the same thing as NemoClaw? Wait a second. So if these two things are the same thing, that means that I have to pick either of these, and then whatever the fuck this is a mandatory selection. But you didn't bother saying that here. However, you're just going to put it there, and then if I don't understand, you're going to tell me I'm stupid. But you can do this like with extreme laziness, and that's okay. So this is where I'm going to start pointing out, like, this is why, I mean, with tech companies right now, I see the AI winter is coming. Because I meet your customers, I meet your forward deployed engineers, and I can tell you this is why a lot of things aren't working, is because like the brain rot and the collective hallucination has gotten to be really far. So what I'm now doing is I'm saying, look, I think that this selection was quite stupid because these two, OpenClaw and NemoClaw, are the same thing. And then let's go to NemoClaw, and then let's understand what OpenShell is in relation to NemoClaw. Oh, NemoClaw comes with OpenShell out of the box. So my options in actuality, now so what I don't like about this, and the reason why I have such a strong reaction to this, is that, like, don't be coy. This is like, and I'll take a second to define what being coy is. I hate Perplexity. It used to be great. Perplexity used to be amazing. I understand they caught a brick. You're acting shy, quiet, unsure, often trying to be cute, flirty, but you're really just trying to hide details. You want us to do something, you won't tell us it out loud because you didn't figure that out inside of yourself, because you are just throwing shit at the wall and then blaming the builders on, like, oh my God, no one really wants to build. Because who the fuck wants to come out for 12 hours on a Saturday, longer than a work day, and do things that your own employees won't do? Like, hello, you got to get real about this. All right. So, what I've now done is that for the stack requirements, I have just immediately understood that, oh, and then let's take a look. No remote. Hold on. And then and now this is where I want to call out even more of the stupidity here. So there are no remote LLM API calls in the agent's runtime path. Oh boy, are we going to have a fucking problem here. Let's talk about why. Let's go into why. So to understand why, we're going to need to take a look at our actual hardware. So we are going to have a large language model, which will then be deployed or be like put onto a machine, and then we'll use it inside of there, right? So let's take a look at the specifications. So memory, we have a lot of memory, 128 GB. So what I'm now going to do is, like, thankfully, there's an incredible resource called local.ai. So let me come to local.ai. I'm so happy that I have an account. I have invitation links, which I will also include inside of here because I really believe in local AI. I just don't believe in companies that have bad hackathons. Okay. But my friend is doing it and I love my friend. And when your friends do stuff, even if you think it's a little stupid or silly, because Somya is my friend, I'm going to be like, yeah, it's going to be a great day because I'm going to see my friend. I'm going to meet my friend's other friends, and then our friendship is going to increase. I don't care about your company. And, so I think that's important. Oh, and now this is a great opportunity where I may see if I should try to tell local AI that they should add the Grace Blackwell 10 into this. And so right now I'm only seeing RTX caliber hardware. So the next thing I'm going to need to do is I'm going to need to prove to you about, like, hey, if this is 128 gigs of memory, let's see what models could we realistically fit on here and how the fuck do they do on the benchmarks? Because now we're gonna have a problem here. And so let's go into looking at the best models that are going to run on certain pieces of hardware. And so what I'm going to do is and I'm surprised, let's look at the M5 Pro. I think this one will be the optimal strategy. And so look, now thankfully we can see here that when we see the most intelligent model, we need intelligence. What size of model are we realistically going to be able to work with? Well, a 27 billion parameter model. And the reason why is that when the 27 billion parameter model is activated inside of its runtime, it will actually take 54 gigs of memory. Now, if we also combine that with other things on the machine that will also take up space, such as Docker on its own will take 7 gigs. And then if I have an application runtime, because I can't just have AI on a machine, I'll need to have some application runtime because it's not just about having intelligence, it's also about having the rails. And so now I can postulate that realistically, a 27 billion parameter model is going to be on this machine. It will be 54 gigs of RAM. Depending on the context window, it could potentially take up more as well. And then in addition to that, I got to have space for Docker. Okay, fuck. And now you see this is what the problem I'm saying is. However, I need to actually get to what this number is, and then we're going to look at the appropriate model for that. And so what I'll need to do is I'll need to benchmark because unfortunately on local AI, this currently isn't like the hardware selection is not currently there for what I have. However, I definitely want to yeah, I definitely just want to look at this. All right. So now we have the RTX 5000 class. So let's take a look at that one. So RTX 5090. And I just want to take a look at the specifications. So I'm going to hit specs. Now the memory config seems to be quite small. So it may be that, this hardware and the appropriate comparison, I mean, now this is where I could be wrong. The appropriate comparison could potentially be an H100, but that seems kind of ridiculous to me. So I'm gonna stay with local AI. Now I'm gonna move up. Let's go to RTX Pro 6000. I want to do a quick test here. So I'll go to Google, RTX 6000 Pro. Let's take a look. High end. Okay, this is even bigger. Video memory, CUDA cores. So these are things that I want to be cognizant of as I'm thinking about what's going to fit on this machine. And so now the first issue that I'm immediately running into is, okay, well, how do I select what machine or which models are going to be able to fit on here? So a simple technique that I will try to use to get around this is going to be to use AI. What I will do is I will come over to Claude, and what I will then do is I will say, look into this and tell me which local models will fit on there and why. Check Hugging Face, leaderboards, as well as open code to give me ideas. And then also inventory, NVIDIA's use case and reference architecture library to tell me the best use cases for this. I'm doing a shitty hackathon. And then what I'll do is I'll just grab this. All right. And so what I usually love also doing is I love like going through the reasoning trace. And then I get to see like, well, what things are going to be on here? What are going to be my potential options for thinking about things? I can see all the places that it is going to go. Okay. And it looks like NVIDIA has a post on this. So introducing NVIDIA Nemo Claw. This is about accelerated computing. Aha. Okay, so now I'm gonna need to understand. So this is the tough thing is like there's too many damn acronyms and like there's no organization of this. Oh, okay, shit. So I could come back to local AI and now at least I get it. Like, so from local AI, I could look at this and now this is gonna be my model selection. So look, this is the thing that I wanted to get to. Even on this super powerful machine, like my best option right now is going to be Qwen 3.827B. That's going to be my best option. Um, and then Step 3.7 Flash is going to be the one that has slightly more intelligence. So let me click here and I'm going to look at this model. I'm going to have to understand it. And then look, there's intelligence and then there's disk size, right? So like what we're going for is we're trying to go for intelligence density. I don't get enough signal from this, but that's totally fine. And then, yeah, this is the variation of the model. I'm gonna see like, all right, for this model, like, why would I even trust this shit in the first place? So what I'm now going to do is I'll come out of local AI and I'm going to go straight to where this is from. And so this is coming from Step Fun. And so unfortunately, I'm not even familiar with this AI lab yet. The new frontier agent is efficiency, flash model for real world agents. I mean, these benchmarks look impressive, but I mean, like a lot of this stuff, like I think it could be cap. Um, okay, so the next thing I'm actually going to do, because I can't, this is a website. You never want to trust a website. I find that to be, especially like probably one of the worst things you can do is trusting a website. Um, what is interesting here is that this model size is 201 B parameters. And how is this going to fit at runtime? I don't know. And additionally, are the weights open? Or is this something where they want to serve this? So that's going to be something that I will also look at. It looks like the weights are open. I'm seeing the footprint on this. Yeah, so 198 parameter model, but it has a sparse mixture of experts. So when you have this type of architecture in a model, like this will only activate a set number of parameters at runtime. So this will not like take its full size. This will actually be slightly smaller at runtime. However, fitting the model on the machine could be problematic in the first place. So that's what I'm currently trying to inspect is what is going to be the memory footprint of this. All right. So as I'm continuing to read this, like immediately, like, a great benchmark isn't going to help me adopt this. And then what it turns into is that, okay, great. Let me do all this extra homework, right? Like, no one really wants to do that. So what I will do instead is I'm going to come back to Google and I'm going to ask for agents last exam. This is a meaningful benchmark. This is a benchmark that specifically is designed for economically valuable real world tasks, right? And so if I look at the leaderboard here, I will be able to see which models are best here. And what I notice here is that there are harnesses that can be selected. And depending on the harness that you choose, plus the model, this is going to do stuff, right? So what we will now do is I want to take a look at what's going to do the best. And I see Codex does the best, but this one isn't open. Kimicode K3 is open, and this does the best. However, let's take a look at the size. and if this is going to be something that can actually be served. From Moonshot, 2.8 trillion parameters. Wow, 2.8 trillion parameters. So that is exceptional. That's way too big. That's not going to fit on here, right? So now we got a problem. What I will now do is I will keep looking. So now we have Qwen 3.8 Max. So let's take a look at that. So we'll do Qwen. I'll come over to the company page. And then what I will do is we will look at the 3.8 family. Oh, when they say max, I think this is what they're talking about. Now I'm going to click this. What's the model size on this? 2.4 trillion parameters. That's big. This is big too. So what I'm now going to say is that, okay, well, I guess I can't use this either. All right, now let's take a look at GLM. Let's look at GLM. 5.2. 753 billion parameters. So again, this will not fit on this machine because when we take a look at the memory overhead that we have, this is what we're working with. Oof, oh boy. So then what are we going to do? Oh, Qwen 3.8 27B. Okay. So that seems to be the model. And then that benches against Cursor's Composer. So then, and then these seem to be tied to some degree. However, like it's looking like Qwen 3.8 is going to be the one. And then I will look at Cursor briefly. Okay, this doesn't look like their organization. So Composer, and this may not be here. So that's totally fine because that's their model. I don't think that they're opening that shit. All right, so that's just the CLI, and this is going to be only for using Linux. So my best option for building while I am at the hackathon is going to be using Qwen 3.8 27B. Additionally, we will not be able to download models the day of. So I will have to get this onto my own local hard drive, and that's where we will begin. So first and foremost, I got to say, this is why, again, this is stupid and sophomoric because they're being coy to hide the fact of saying, all right, first and foremost, like, we're not even going to acknowledge that OpenClaw and NemoClaw are the same thing. Like your only option is using OpenClaw or NemoClaw, and you must use OpenShell or you can't win. Because if you have a submission and you're using OpenClaw and NemoClaw, I'm going to have to look at it and be like, well, that just seems kind of stupid. So really what they're saying is that no matter what, you're using OpenShell. And that then when it's time, then the next thing is I'm going to have to look at is that, oh shit, like inside of OpenShell and NemoClaw, how well is this Qwen 3.8 27B going to perform inside of there? Now I understand why they're doing the hackathon. This is really expensive to have someone test it. And NVIDIA and Dell's own forward deployed engineers do not have anything for this. And so they want to ask a bunch of people to do this for free so that they can see it and then it's done over the weekend, and then they can just harden whatever we make later, not compensate us. That's the goal of the hackathon. So you got to remember, like, everything really comes down to game theory, and you have to remember these types of things. That's why I'm keeping a picture of Jung here, because I don't want to get lost in like, oh, there's a hackathon, it's this and it's that. Because I mean, look, it's like I would say the current state of AI and people talking about AI hackathons and building, it's just as ridiculous as everything else you see on TikTok. There's minimal merit to what I see in the current AI market space. All right, so what I'm now going to do is we know that we must use NVIDIA's open shell runtime. We must use the other parts of NVIDIA's agent toolkit and take a look. Oh, you know what? They probably want us to use their model too. So you didn't have to be so coy. You could have just said, hey, look, technically you can use everything. This is our recommendation. If you want, go look at all the other things you can do, but this is what we recommend. But instead, right? Instead, you want to play coy. So now I'm coming back to Claude. Let's take a look. So NVIDIA GB10 Grace Blackwell Superchip, 128 gigs of unified memory, 273 gigs of memory bandwidth, and then the operating system is DGX. Okay, so then these are going to be other things that I'm going to think about. This means dense models get punished and MOE models win. Okay, so I need to pick a MOE model. That's the issue, is that if I need to pick MOE, mixture of experts, like, then what's my selection size going to be? And now, oh boy, let's take a look. Right? So just by reasoning from first principles, we can get to a much better answer. So, oh, my best option is using what the house is making. Nematron, 4 billion parameter. It's dense and small. It's the reference model for GB10, actually. And this is what NemoClaw defaults to for its lightweight agents. Oh, duh. Nemotron 3 MOE Super 120B. Aha, and it fits at this. So now we're going to need to understand, is this shit going to fit in the first place? Or maybe it won't, because now I got to understand what's this. Let's see if this is on the page for Dell. It is. So I need to contest. Oh, okay. All right. Got it. All right. So look, we're already really like kind of understanding limitations. And I'm going to note this for Nematron 3 Super 120B. Then, of course, we're going to have Quen. And then we have GPT OSS. So this is 120B. And so notice like these manage to fit. And I'm going to need to understand like how well they fit. So I'm going to say for each model, help me how they will fit and be at runtime if using NemoClaw plus OpenShell for an ambient agent. Let's say we pick their ambient agent for healthcare architecture. Would that fit all onto here? And what setup? So now, like this is where I'm saying we have the problem. All right, let's see. All right, so damn. So now we understand like this is why I'm saying that immediately, kind of the hackathon concept sucks. Because as I just mentioned, like what's the difference between OpenClaw and NemoClaw? They're the same thing. NemoClaw is a superset of OpenClaw. Open shell must be used no matter what. Now we have a severe limitation of what it is that we can use. We have a severe limitation of what we can use, and you're telling us at the hackathon we won't be able to download the models at runtime because we won't have enough bandwidth, which is totally understandable, but you won't even tell us what the optimal models are. Otherwise, we're just stupid builders. Oh, we're stupid, lazy builders. Meanwhile, your own employees won't figure this out. This is why AI is not successful in America right now. Walk down the streets, you'll see AI is not effective at all. And this is one of the big reasons why you're going to see a massive consolidation. This consolidation is going to happen through mergers and acquisitions, and predominantly just because like Twitter is going to applaud that and will stay in that hallucination. But your companies are bleeding money. Your 22-year-old floor deployed engineer isn't explaining things properly, and your company culture is the reason why your companies are failing. There is the like having an ultra broy culture, and all of your cultures in the whole AI infrastructure industry is extremely broy, and you still can't see it yet, but you'll see it by Christmas. All right, so as I continue going through this, like they do have a named blueprint here, ambient healthcare agents that's split into two blueprints. All right, setup order for the day. Blah blah blah. Um, HIPAA, PHI handling exactly why local. Shut up. It's so stupid. Um, all right. Stand up the MP. Okay, what will we be able to enable by doing this? And then how would we test this in a sandbox virtually first and then verify this, and then how would we test this in a sandbox virtually first and then verify this, and then know what is needed to build the last mile. And I'm not going to use too much reasoning. I'll just use Sonnet for this. I don't really need like the full advanced engineering. A lot of times I'm just looking at the traces too. So they do have their ambient healthcare agents repository. So why don't we just go to that on GitHub? So I will now come over to this NemoClaw. Let's click on this repository. So supported agents, blah, blah, blah. So look, like our options were NemoClaw and OpenClaw. Many people would want to use Hermes. Hermes would be usable through NemoClaw. So that would be, your thing there, or you could use the LangChain Deep Agents code. Architecture details. I'm looking for use cases. Blah blah blah. No. All right. So now the next thing I will do is I will just do this, and we will check this through the NVIDIA repositories. So it seems like there's nothing from the NVIDIA repositories on this yet. So I will just look for repositories. And so this was just in a different organization. So they have AI blueprints. So this is the one that we will pull from. Now, immediately, because this is talking about voice, this doesn't seem like it's tenable. So what I will now do is I will just paste this in, and I'll say, okay. Yeah, this repo is not going to run on that. I realized that. I was like, there's no fucking way. Not a damn chance. Swap the reasoning model for a quantized model. Build only the provider, skip the patient. So what's the ambient provider use case? So look, the economic value. So now what we're going to need to do is like, we only have two things that can be picked out right now. So one is doing like something for being patient focusing, or something that's going to be provider focused. And so the next thing I want to do is I want to come over here. Let's take a look at agents last exam for what they actually care about. What are the tasks that are here? So we'll give this a second to load. What I will then do is I will click on what I see. So there's clinical diagnostic. Notice how, so there's clinical diagnostic, but there is not saying, oh, this is just like patient care. So it appears to be that in terms of economic value of what is possible with an agent, normal patient care is not something that is benchmarked today, because like this is still not something which is actually economically valuable. So this is a passive documentation tool. It listens to a patient-provider conversation, live or from a recording, transcribes it with the speaker diary, and then generates a structured note. Okay, guys, I got to get real with you. This is not worth it. This is so not worth it. Let's look at the pricing. A single machine is $7,000. Then you're going to have a person who needs to operate this, update it, secure it. And then every room is going to have one of these. And then how often does this need to be replaced? I'm going to say every 3 years. It could be every 2 years. So now that's called amortization. So we'll amortize this at a rate of $2,000 a year. So about $200 a month. not including the overhead to maintain it. $200 a month, you can get an ambient AI agent for your practice that runs in the cloud that will handle HIPAA. So, no, this is not worth it. Oh boy. Um, okay, so what we're now going to do is we've realized that this first use case is like, this is bad. This is not going to work. So let's come back. Okay. We're going to have to take a look at what are going to be other real things that we can do. Retail agentic commerce. So thankfully, we have a lot of repositories here. We have 37 repositories. And as we have 37 repositories, we will have to actually click through these to understand what's going to be a good use case, what's worth trying. All of these are also not agents either. All right, this is just data analysis, super basic. And we'll have to read this and we'll have to take a look at like what are we expecting. So we see Gemma 4, 31B, Nemo 3. So this seems like it could work. However, part of the rules here, let's take a look at the rules of the hackathon. No remote LLM / API calls in the agent's runtime path. Womp, womp, womp. Okay, so we won't be able to use this either because data analysis on its own doesn't matter without the internet, damn it. Doesn't matter without tools. Unless you want to build all the tools from scratch, in which case, like, all right, you're just reinventing the wheel. So let's keep going. So let's think of voice. Voice agents, they usually do well in a hackathon. Let's see. This could fit. So what I'll do, and I think it's going to fit because it works on a Jetson. What about this? And then we'll just design a simple enough use case for it, and then we'll see if we can just call it a day. All right, the hardware table. Shut up. The Claude speak is like I'm starting to see more and more people like they actually talk like Claude. They don't talk like themselves anymore. Why this changes the plan? Oh my God, shut up. Can we use this? Yes. No. How much overhead does this take? 3 bullet points on what I should know. Okay. I need to scope economically valuable use cases for this in the enterprise. Um, just the voice job healthcare. Because another thing is like the enterprise, like they care about cash. All right, so like call centers, no, this isn't going to really replace call centers. I think that's stupid. 24/7 inbound, after hours support, appointment booking and scheduling, lead qualifications, outbound sales is not going to be, this is not going to work for outbound. Collections, I mean, okay. So far, this is just extremely weak. Um, yeah, this is extremely weak. I have to say that so far this is like terrible. Um, but we have a lot of room left. And so where I'm wondering is like, okay, like this is an end-to-end voice agent. Make sure that it makes no API calls. So let's take a look at this. The user connects using real-time communication. We'll use Nemotron TTS. This will process this. There'll be a context manager, and all of this. Multilingual assistant. So I think this can be quite helpful. So what I'm gonna do is I'm gonna be like, since it's multilingual, let's make something for New York City, such as people trying to report small problems like potholes, understand what the NYC government already has in place, for doing this. They may have something like 311. NYC also has tons of open data that will help us know which use cases to include for easy training and handling majority of edge cases. While we're at it, why don't I look at my plan? I think it might be time to downgrade my Anthropic plan because I am on the Pro plan, but I have to say it's starting to suck. Hate to be so bearish on AI today, but right now I would say like it's bearish in terms of like, when companies try to do fake things, like it's always going to be bearish in that way. All right, so 311, it's a mature system. Oh, okay, that's nice. Blah, blah, blah. All right, so it looks like, what I'm gonna do is I'm gonna try to do something that's like 311. You can call it. Um, so I think that that's gonna be the move. All right, so today I thought that I was going to prepare for the hackathon. My goal was to learn out loud, know when I'm wrong. And so we started by saying, hey, what's the hardware? We need an always on business agent. So, always on, that's a big thing. They want an ambient agent. So, we are correct in being like, okay, it's going to be ambient, it's going to respond to things. For it to have deep capabilities, that's where we know that deep reasoning capabilities, this hardware is best suited for a mixture of experts type of model. However, like in terms of deep operations and having the overhead to do a lot of meaningful tasks, will probably still fail. As we looked at the type of reasoning that's required to do a lot of deep, long horizon tasks. So we'll just try to stick to basic voice. We'll have a single agent. We also know that, like, okay, this was kind of stupid and sophomoric because they were being very coy about what it is we're doing. They want us to make sure that we use OpenShell for this use case to keep everything nice and secure alongside of NemoClaw, which is really a superset of OpenClaw. So they wanted everyone to know, hey, OpenClaw has your mind share, but when you need to do something for work, you need to use NemoClaw. And there's a reason why they didn't give you the extended option of using Hermes on your own. They wanted to control you in how you get to use it. So I think like that's one of the top things that I noticed. Then, all right, so we have to use NemoClaw OpenShell. There can be no remote LLM API calls. So we have a severe limitation in what we can do for reasoning. And if we have a very big problem with our ability to do reasoning and the hardware is also crazy expensive, when we think about, business and corporate use cases, this means that, okay, well, the ambient agent is going to be problematic. Now, of course, the other thing is then going to be saying, okay, well, like doing 311 technically is not a business use case, but what we will do is we will prove that if it can work for the largest city in the world, you would be able to use this too. Um, right? So I think that that would be something where it's like, all right, now you could have a system that is kind of modeled based on, you know, New York and back tested in New York. So therefore, it should kind of work for you, and then you can kind of create um, some type of system around that. Um, all right, but that's about it. I have to say, this hackathon, it's probably not worth more of my time for the preparation because the hackathon organizers don't care enough to provide any meaningful details or to think things through. Um, Now also, like, let's take a look here. Like, this is also where, I mean, I guess we'll kind of end here on why I'm kind of specifically calling this out as stupid. Is that, let's read this. Where's this shit? Submissions must target a real business or corporate workflow. Toy demos, joke projects, and personal assistant clones won't be judged. I'm just like, a human didn't write that, and that's just beyond stupid to say. That is beyond stupid to say because you didn't scope out anything in advance. And so you're really just being so lazy here. um, so I now know like what is possible in here. I know how much to prepare and I know how much effort to give this. I probably won't live stream too much more about this particular hackathon. It just doesn't seem to be that strong of a use of time because there isn't that much possible and no one who actually even works at the company, this is $1 trillion company, and then Dell has a direct line to the president. Like, none of these companies care enough. And so if they don't care, you also shouldn't care too much either. I think that's another thing. I see a lot of people, they do hackathon to hackathon, but then they're really just broke. Um, because if you're going to spend 12 hours at a hackathon and then you're going to, you know, it's an hour to get there, an hour to get back, and that's your Saturday. Um, it's good when you see a friend and you can do something for a friend, but beyond that, like, this hackathon is kind of cooked. We'll see what people make, but nothing commercial is going to come out of this hackathon, given, and it's not because of the builders. It's because it wasn't well thought out. And because it wasn't well thought out, there's such a misalignment between, you need to give us a real business workflow. Um, so they're really just trying to attract people who really want to get a job and they're highly qualified, and startups who like have that 996 type of culture, which I also think they're going to fail so miserably. So I think, I'm going to participate in the hackathon, but I can guarantee you none of the insights that come from this hackathon are going to matter come time for December. And at whatever the hell you see happening at this hackathon is going to be irrelevant come time for December. I'm predicting an AI winter for a lot of what's happening in the venture ecosystem. I think New York is going to be in for a very rude awakening once we start seeing a very big consolidation through mergers and acquisitions. We're probably going to see a lot of teams where, the company gets bought, but it's going to be very similar to like a windsurf, where the founder gets bought, the rest of the team gets gutted. I hate to be so pessimistic, but in this case of like, this is a real market reality company, like this is what your top AI companies are doing to get use cases for the rest of the market. And immediately we're seeing the math is no longer mathing. The builders aren't going to be able to do anything novel that's magically going to save them. So I'll report back next week on what happens. Um, the only thing I have to say that I regret in this moment is I wish I would have just taught my own curriculum for business calculus. A lot of people will usually complain like, oh, like do the things that are deeply, deeply, deeply technical, and try to do that. But as we see, the startup ecosystem and your startups who are kind of stewarding a lot of a lot of the hackathons, whether it's NVIDIA or whether it's like LangChain, I go to your events, and the fact that you guys are just ultra broy, where 9 out of 10 people on staff is a guy in his 20s, this is where it's going to show, because you're not doing anything meaningful for the landscape. If I'm wrong, I will gladly come on live stream and admit I'm wrong. If someone does something truly novel and really breaks the base, but given what we know, given the size of the model, the only thing I think that we're going to be able to do is we're going to say, hey, look, this 27 billion parameter model has a capability. And it's a capability that we've already seen in a bigger model. And now I've taken that capability, I've wrapped it in a harness, and now I have a hypothesis that we're going to commercialize this. But nothing that's going to change the world is going to come from this. Nothing that is really going to enter and penetrate into a market is going to come from this. And this is because we had to reason about what is actually possible today. And what is possible today, given the machine we're going to run, is that we're going to be able to fit in a basic reasoning model. It'll be able to do some basic tasks, and it should be able to do some basic corporate workflows. But that is about it. So I'm not going to spend any more time on this. I'm actually just going to message one of my friends of like, hey, I scoped out some of the use cases, just doesn't seem promising. And then I'm going to realign with him, because that's the other thing. I'm going to align with other humans. So I have my friend Rex. I'm going to be like, hey, man, look, like, turns out that, this shit actually kind of sucks. And that we should probably just get realistic on like what's actually going to be possible, because a lot of what you might be thinking isn't going to fit onto the hardware. And let me explain why. And we'll probably end up doing a voice demo that tries to solve it's like some type of multilingual triage. All right. I wish this was a better one, but we have to use what we have. All right. So that's today's live stream. Keep trying to participate in hackathons. I think in the future, what we will do is I will make a list of hackathons that actually try to do things that are much better. I will specifically in the future, before I consider doing another hackathon, to think about doing something with someone like AGI House. And so, I think this will be where I want to end the video because the previous hackathon that was organized by Builderbase right here, I find that this was stupid, and it was stupid because they were specifically being coy about the requirements of what you can use, as well as the fact that they themselves did not think this out. I think someone at Builderbase was probably just not even thinking, and just being like, oh, hey, like, let me just have Fable 5, like, do my work for me. Instead, what I will do is I will look at what is happening at AGI House. And in the future, I will only think about like what are some of the things that I am seeing here. And I also do see that there is a voice agent build day. And so what I will do is I will try to take a look at what projects are here, what has been tried, and I will lift prior art from AGI House in the future. And I will no longer look at anything, any hackathon happening in New York City as something that I'm going to really try to prepare for because the culture the culture doesn't believe in exceptionalism for New York right now, for the hackathon culture. So for the future, I will try to take a look at AGI House, as well as I'm also going to take a look at what my mentor is doing. So I have many mentors, and I have one mentor, Will Sentinence. Oh my goodness. Will Senta. This is so bad when you can't like spell your mentor's name. But Will Sentinence, he's done some of the greatest courses on JavaScript. What I will do instead of thinking about a hackathon and thinking about what a hackathon is telling me to do is I will think from what my mentor would have me think about. And in the future, I will never listen to predetermined requirements from a hackathon unless it is from a source like AGI House. I will no longer listen to any New York City tech events. I'm just going to kind of go and have a good time. And when I want to do something that is really hard, I'm going to go back to think about what would my mentor Will say? What would my hero Jung say? And from there, I will use my imagination and I will do something that is actually meaningful, that moves the needle forward. Because as we see here, like when we play a stupid game today, I just lost my morning and I won a stupid prize. So today is probably the worst live stream in the series, and that's okay. We will return back to business calculus. This was an experiment for me to just see first thing in the morning, could I try something new and different? And, I really wish that I would have done a stream to talk about what I learned about Jung. And that is what I will focus my time on. I will focus my time more on what I am learning from another human. I will no longer spend my time reading the AI generated output of another human who did not have the correct intentions when they were putting this together. All right, so that's the end of today's stream. Hopefully, at least you get to see me how I get to think through this, and I'll see you in the next one.